Hello everyone. In this video, I want to talk about the answer to an interesting question asked by one of my students in my CAD class. And he asked that if I have a part like this, and you have, let's say, a bunch of holes, and these holes are very similar in diameter, then when you want to create drafting for it and you use n times for the multiple features, how would you show which ones are like the one diameter and which ones are the other one? So here, if you look, the first one on the top row, and the second one and the last one are zero point 0.6, and the other six are 0.59. Okay, and so if I want to go and create a drafting for this, how do I do that? So let's take a look at the answer to this question. So here we go to the drafting, and this is the drafting environment, and I use the whole callout command and clicked on this one, and it says 5.6 times depth of 0.5, and I know I have three of that, so I showed three, and then I clicked on this one, 5.59 times depth of 0.5, and I know I have six of that, so I said six. And you also need to provide the offsets right here. For the top one, you need to locate the first center, and then if they're all horizontally aligned, you need the horizontal offset. And the bottom one also, you need to locate its x and y here. So you need the x of it, you need the y of it, right? And you really need to add this one here as well, the y of it, and then you need also these offsets, so you need to provide these offsets too, okay, because this part is no symmetric, so you really need something like that, okay. And now the question is, how do I know which one of these diameters is 0.6 and which one are 0.59? Okay, how do I do that? And here, because I have pattern, I don't need to show the other dimensions. But if there's holes were completely just distributed at points that have no pattern, or kind of like not random, I would call, but in locations that make no pattern with each other, then you need a lot more of these dimensions. Okay, so how do I go about showing which one of the circles is what diameter, and how do I avoid this drafting to be over crowded, over busy with lots of dimension lines? Okay, because one way you might think of it is, hey, I use some tags and some notes and maybe call this dimension A, and then I go here, and on all of these that have shared the same diameter, I say these are A's, and the other circles, maybe I call this B, and the other circles that share the same diameter, I call them B. Okay, or because you don't want to use a bunch of these whole callouts on each and every one of them. This is a repeated feature, so you want to use n times, you want to use the multiple feature symbol, right? Because yeah, you can do it on each and every one of them, but that's not really what we do in typical drafting. So how do I do that? And how maybe possibly getting rid of all these dimensions? And the answer is the command called whole table. So it's under the tables, it's the whole table, and it's a very beautiful and powerful command. So click on this, and if the holes can be described by their XY coordinates, choose XY. If they are radial, then use radial here. So this is good for X and Y. Set an origin. Now here, maybe based on the datum that you have, this is your origin. So we go for that as the origin. And then here, for these edges, you select all of the holes that you want to specify their location, their diameter, and their depth. So choose them. You can even window select them. Seems like I selected the face. So I need to get rid of that and just select these edges, and there we go. Look, simple as that. I have created a beautiful whole table. Look at that. So it shows me where each and every one of them are with respect to that corner, as you can see here. the x coordinate is measured from this edge and the y coordinate is measured from this edge, so that point is origin. And the beautiful thing that it has done is, if you can look, it named all of the holes with diameter of 0.59, called them all A's, A1 to A6, and those labels are right next to those circles. And the 3 that have diameter of 0.6, call them all B's. And you clearly see the coordinates are correct, right? So look at this B1. You see the coordinate of the center of it is 0.8 and 0.8, and this is exactly what you can see, 0.8, negative 0.8. Negative because y is negative. Or for example, for A1, y is negative 2.4, which you can see over here, right? So once that is the case, then I do not need any of those. Do not need any of these dimensions, and I do not even need these whole callouts. Okay, so you see how efficient is that? All you need is basically this one, and that will take care of everything for you. Add the labels, proper labels, depth, diameter, location, and this is really, really efficient. So hopefully it was useful to you, and I'll see you in my next video. Thank you.